Okay, so you will require a microcontroller, which is you have to purchase yourself, or you have to wait until you came back to the university, to my lab, to be able to use them. Um, but I really hope you get one. Okay, I really hope you get one, because this subject is about that. It's about microcontroller, sensor, actuators, relays, and some other electronic component. Um, but nevertheless, you can install this Arduino IDE first and make sure that you are prepared for the for when you have the microcontroller in your hand. But the installation guideline here, this is basically, unfortunately, this is for older version, but more or less they are the same, except that they move the menu here and there. So you can just follow the tutorial, but you can still download the archive version, the 1.8.4 version, or any version that's below 2.0. But I would suggest for you to use the latest version, because the latest version they came with quite nifty tools, features. So I'm going to use version 2.0. So the installation basically just a straightforward installation, just download and then install, follow the installation. However, the requirement for the Arduino to be able to use with ESP, because ESP microcontroller, by default, they are not supported by the Arduino IDE. So you have to add those two to the board manager by using the menu for the board manager. And for the Arduino IDE 2.0, version 2.0, the menu basically, you can go to the file preference. So it's basically here, go to the preference, it's basically down here. So you need to add those into your list, additional board manager. Once you have the list here, inside here, then you can go to tools, and you can go to board manager and board manager. And the menu is here. The older version, basically, they have it on floating on top of the IDE, but the latest version they have it on the left side of the IDE. So here you can just look for ESP8266 if you want to use with ESP8266. The current version that I have here is 2.7.4, but depending on the usage, sometimes the latest version for the board, they might have some issues with certain library, so you might have to test them, okay? So it depends on your usage, it depends on the microcontroller itself, on the library itself that you use. So yeah, the version that I use is this one. So far, it works great. Unless there's a new library that I require, then I'm going to update them. If you want to use with ESP32, you can just go search for ESP32. So you can just, the one that I use is by Expressive. Even they have the Arduino version of ESP32 board, but I don't have the Arduino, because nowadays Arduino, they somehow like they joint venture with Expressive, and then they embedded their Arduino IDE board, the Uno, any of their microcontroller with the Wi-Fi capability. So, which means that they have to connect to the ESP32 or ESP8266. Okay, so you have those if you want to be able to use them. But usually, if you're running on ESP32 by Expressive, you just install this version. So the version that I have is version 2.12, but I believe you can just update, because the current versions does not changes much. Okay, so if you want to go with the ESP32 route, so that's basically the first. That's basically the board manager. So once you get your managers sort out, you can start with to test the IDE with your microcontroller. All right, so here, this is the LED blink test. And the LED blink test sort of like hello world of programming in microcontroller. So it basically allow you to control. Just turn on the camera. Camera is on, but I need to see, where do I need to see them? Video setting, where is it? Self view, show as a sign with show is floating windows. I can see that. This is height, this is show. Okay, advanced video setting, GPU acceleration should be okay. This is minimize. This is video. Don't mirror my windows. Should be okay. Save view location. I want to change the size. Zoom to fit. Should be okay, but I want to increase the size here. Show me in front of presentation. Something like that. Yeah, this is the one that I used last time. Okay, let me just increase this a little bit. Should be okay. To the left, nope. So basically just use the entire screen. Video setting. All right. Setting should be okay with that. I'm going to sit down right at the bottom down there. Okay, so now let's see if we're able to use the code. It should be very simple. So the first thing that you need to do is just to create a new sketch. So in Arduino, they call it a sketch. The file format here is a .ino. So the .ino is the Arduino file format. So whenever you create new sketch here, so I'm going to create a folder. Later, I'm going to save them. So I'm going to close this one. So I'm going to use this one. Okay, so by default, it's basically going to create this default code structure. Okay, you have your file name here. They call it sketch April 8A. So because it's basically today. And then this is basically the default code provided, which is not much. There are two functions, setup function and loop function. Okay, so these two very important. So whenever your microcontroller run, it's basically based on the I forgot one more thing about the installation, but that one I'm going to do it later. Okay, so there are two main functions here called void setup and void loop. So these two functions basically they have their own purpose. So the setup function, this is basically when your microcontroller first run. Okay, so when your microcontroller first run, basically what they're going to do. Where is it? My ESP. This one is ESP32. By the way, I put it my ESP. I got an ESP32, but should be okay. All right, so this is basically when you power on your microcontroller, your ESP microcontroller. So the first thing that the microcontroller going to execute is the setup. Okay, so it's going to run this only one time. So the function of setup is used to define your variable, to define your object just one time. Okay, so it's going to go through the setup. If you have any global variable that you set up there, or if there's any object class, object that you created, or any other parameter that you want it to run only one time, so you put it there. Or any instruction also, you want to run it only for one time. You don't want to run it many times. So all the instructions is going to be in the setup method or setup function. Okay, here we call it function. Okay. And then inside the loop method here, so the loop method here basically where you want the microcontroller to execute the instructions many times. Okay, forever. This is called forever loop. Okay, so whatever instructions that you need to do here in the loop, for example, like you want to read sensor data. So if you want to read sensor data, you might want to put it inside loop. Okay, so loop will automatically execute the instructions all over again as long as there's a power supply to the board. Okay, so it's going to be inside loop. That's it. Okay, there's only two main methods here. Setup, where you want to set up all the parameter, all the variables, or you want to run the code only one time. But for the loop method, loop functions, where you want the microcontroller to run forever. Okay, basically read data, display data. So read input, wait for input, and then show the output. So those are the job for these two functions. It's very simple instruction. All right, so you can see it here. So this is very simple instructions just to blink the LED. Inside the setup mode, there's an instruction here, pin mode, LED built-in. This is constant, and we set it out as an output. So because we want to display LED or we want to turn on the LED, so the first thing that we need to do definition, pin mode definition. So the pin mode definition, basically what it does, what the function is, the name of the function. What is the mode of the pin? Okay, the pins that you have here. And even though the instructions like LED built-in, okay, so the LED built-in, there's a two LED available on this microcontroller. The built-in LED that on top on the microcontroller on itself, and the LED built-in on the board itself. So there are two. The LED built-in is basically the one that with the microcontroller, the up here. And this LED built-in basically connected to one of the pin actually. Okay, they're connected to I believe pin 0 or pin 2. I forgot. I think pin 2. Okay, they are pin number 2 here. So they are basically directly connected. So whenever you define LED built-in 2 or LED built-in, so that parameter already or that constant variable already been defined as pin 2. Okay. And then we need to define, okay, this pin mode is an output, means that you want to output voltage value. You want to output value, okay, to the pin. Either you want to turn it on or you want to turn it off. Very simple. So, if you put in instructions, hold on. Okay, so let's try to write something here. Okay, so call it pin mode. Okay, you can see the IDE basically show you the format of for the function. Okay, and then you can just put it your passing parameter. So the passing parameter require two input. So one is the pin number and the other one is the type of operation that we want it to execute. So here we can just provide LED. You can see LED built in there. Okay, and the type of operation that we want it to be implemented as an output. Okay, so then stop there. All right, Control T to auto arrange. Okay, so just supposed to be able to zoom out to forgot how to do that. Oh, I think this one. Oh, alternate. Oh, shift. This one is serial monitor. No. How do I increase the size? Is it a file preference? Editor size. Let's try 18 so that you can see much clearer. Yeah, there you go. All right, so now you want to execute inside loop. So inside loop, we want to give instructions. First, we set up the pin mode. So we set a pin mode LED built-in to output, and then we want to execute on the pin mode. Okay. So to execute the pin mode, we have the what we call instruction functions that to manipulate or to give the instruction to the pin to do what. Okay. So the instruction here is digital write. Okay. So digital write means that you can see the number of digital there. So there's a digital write down there. Okay, so put in digital write. So the requirement for digital write, there are two requirements there. One is the pin number where you want it to give the instruction to. So here, give it to LED built in. Okay, so the same. And the value that we want it to execute. So for ESP82 or ESP chipset, usually it uses what we call as high-low. High is low, low is high, the other way around. So I'm not going to say the reason why they do that. But so if you want it to turn on, you can just give the value low. I think so. Yeah, I think sometimes I forgot about that. All right. So if you just stop here, means that the LED light will turn on all the time. Okay, if I'm correct. But if you want to turn it low, so you have to switch it to high. Okay. So usually for the Arduino, the normal Uno, basically they use low, low and high, high. So low is low as high and high. But for the ESP, I'm not sure why they implement low, high, high, low, right? So there's some kind of reverse in a way. Okay, but if you just want to turn on things, just leave it as it is. So you can just save. I just want to test also. Sometimes I forgot also about this. So let me just create new folder somewhere on my desktop. But my desktop basically connected to my drive. So if I'm not connected to internet, somehow they disappear. I'm going to put it somewhere else, inside document, inside Arduino. Let me put it somewhere. I don't want to put it inside OneDrive, because if I put it there, the OneDrive will always bug me later on to log in. So somewhere document, is it this one? There you go. I think it's here. Should be okay. Let me just put it here. All right. So I'm going to create a new folder. And this is going to be your later on I'm going to publish it to my GitHub, and then you can use that as a reference. So I'm going to give it the names. SKIH, what is the code here? This is very, I'm not familiar yet with the code. Is it 31? What's the name here? SKIH, this one. Sensor. All right. So I'm going to put everything inside here. All right. So now this is the sketch name. So usually whenever you want to run this code, you have to give it a names, a proper names. So usually whenever you provide the names, it will create a folder for your project. So let's say like LED, or we give it ESP LED example. Okay, if you want to put it like underscore, it should be okay. The example, okay, or that. All right, so any name should be okay. So just save it here. All right, so now the file changed to ESP LED example. And then if you want to verify the code, you can just press the verify button. But usually they will ask you to select which board that you want to compile to. Okay, so here you can select the board. Even though you don't have yet the microcontroller, you can still select the board. Okay, you have to select first, because when the Arduino would like to compile, it needed to know which board that you want it to run or to test. Okay, so here, if this is still null, still nothing, or still ask you to select a board, so you have to select a board. Even though you don't have your microcontroller connected, you can still select your board. So in this case, I'm using Node MCU, which is 1.0. So you can just select OK. All right, so it means that now your Arduino IDE will try to compile by using the board manager library and then compile to Node MCU. But if you don't have one yet, you can give it a try. You can do a verification. So if you press here, you can see the output at the bottom down there. Sometimes you might have to wait a little bit. Okay, there you go. Right, seems to be okay now. So as you can see, this is basically the test compile output. So what you have here is basically will show you all the information about the microcontroller, such as IROM, IRAM, data variable that being used in the program, the raw data, BSS. So those are the RAM heap. Okay. And SKIH basically use 24% of the storage space. Maximum that we can store here is about that. And the dynamic memory. So those are all the informations. As long as you don't exceed the overflow of the memory, you could buffer overflow. It should be just good. Okay, normally, most of the Arduino IDE, I never encounter such issues with the compiling. Seems to be okay. All right, so it means that this is okay. Means that the code is working. If something wrong in the code, like if you put something, hello, something here, right, it doesn't recognize the code. So if you try to compile, it will show you error, as you can see there. So you need to be able to debug based on the output down there. So as you can see, it says that error, hello was not declared in the scope. Little right, so you can see that it shows you the error, where the error that you need to solve. Right, so that's where you have to look into. Right, so let me undo that, and let's try on the real compilation. Okay, so to compile, you need USB cable. Okay. But you have to make sure that you have the data cable, not the charging cable, because the charging cable only allow you to charge, but there's no data bus. So you have to make sure that you have the data cable. All right. So right, connect to your USB, and then connect to your microcontroller here. There's a USB port at the bottom down there, the female part, and then you have your male part, then put it in. All right, my eyes. There you go. Right. So you can usually will hear that so it means that you are connected and they are ready. And how do you make sure that your microcontroller is ready to be used? One thing that you can be very sure is that from your here. Okay, so you can see there's a COM port available that you can use, you can select. So it means that that COM port, that USB COM port now able to communicate with this microcontroller. So when I select the COM port here, okay, so this is the board that I want to use, and this is the COM port that available now. All right, so I can just select on this and then press OK. All right, so now the microcontroller is ready to be used, to be compiled, to be uploaded. But somehow, for the ESP8266 or ESP32, you might be required to install the driver. Okay, there's a driver for this. So there's the installation guide that I have it up there that will require for you to install the driver. Where is it? Down here. Here. Okay, this is upload. This is the code. Where's the driver? The driver. Then the driver up here. Silas driver. That's the name of the driver for ES. Yeah, here. Okay, so Silicon Lab CP210X driver USB to UART bridge COM number, you don't have to worry. Sometimes they give a different COM number, depending on your USB port. So COM3, COM5, COM6, 7. Sometimes you have like plenty of COM port. So they will choose that based on the COM number. All right, so mine, but you have to install first the library. You can download the library here. ESP3113X. Okay, so this is from Silicon Labs. And you can just go to download. Okay, so you can download the driver for Windows. The latest version that they have is this one, version 11.3. So you can download, but this one is universal. The one that I have with the installation is CP Windows drivers. I think this one should be sufficient enough, and then you do the installation. Okay, so you just install with the download. Oh, there you go. Okay, so this is the driver installation, but sometimes they don't come with the installer. So if you want to have the installer, you can use the Windows drive. I think this one or this one. Let me just try first. Yeah, this one better, I think, because there's a driver installation there. So if your computer running 64-bit, you can just choose the installer here, just unzip and then run this, and will help you to install. For Windows, this one, yeah, the same, I think. Okay, so you just choose the 64-bit. Usually your computer running nowadays, 99% they are running on 64-bit. So you choose the 64-bit. But unless you are running on very old computer, so you go for the 3286, which is the 8086 8086 processor, which is a 32-bit, right? So you just follow the installation, and then you should be able to use them. Okay, so those are the installer, and then you can monitor your installation is a success or not. You can check your port com LPT. There should be in there somewhere inside your device manager. You can look for the COM port, and you can see that this is basically the one that we're looking for. And make sure there's no error there. Okay, make sure there's no error. Sometimes you might get error, different operating system version. You might get issues with it because we are dealing with hardware driver. So different operating system, different computer, different machine, they might interact or they might produce different kind of USB. So you have to make sure that you have this. Okay, if you have this, should be okay. If you don't, means that you have issues with the installation. You might need to solve them first, and make sure that whenever you connect your microcontroller with this, and you get that, right? And also, don't touch the microcontroller if your hand wet, or if you're type of person that always get your hand like wet all the time. Okay, with you have issues with your hand, so make sure that you have clean clothes, and then wipe it, make it clean first before you touch them, because this is very sensitive to moisture, to anything that can conduct electricity. And don't put on any metal surface. Like I have my something like this one. You can see my what do you call it, mouse pad here. This is a very large area, so it should be okay because this is just a piece of clothes. It should be no problem. But if you're on a metal surface, don't put it on your metal surface, because if you put like that, it will short circuit everything and burn your chip. Right? Right. So that's basically just a precaution. All right. So coming back to your basic code here. So let's try to upload. So you can clear your output down there. Usually I don't like to see them if I have solved the issues. I'm going to be up there. Doesn't seem too high there. All right. So if you want to compile, just press this button, press upload. I just want to confirm either it's output high or low. All right. So you have to wait a little bit down there. It's writing. Actually, it's uploading the code to microcontroller. Okay. It's doing. Okay. Waiting for until 100% done. All right. Yeah, confirm. So now you can see that the LED up there is turning on, even though I put it low. So this to confirm that ESP8266 use high-low. Okay, they use high-low. High is low, low is high. Okay, what does it mean? High is what? High is 1, low is 0. But in this case, 0 is 1, 1 is 0. I'm not sure why they do that. In normal Arduino Uno, high is high, low is low. But here it's different. High is low, low is high. So keep that in mind. All right. So the LED is there. So if you want to have like a blinking show, just put a delay there. Let's say about 500 millisecond, and then take the digital write again, and then let's say put it high. So every 500 second, and it will try to loop and then do it again. So I'm going to put delay another 500 millisecond. All right. So upload again. This is the thing with hardware programming. You have to wait. Right. Okay, so now you can see the LED is blinking. Okay, every 500 millisecond. So you combine both like 1 second delay. So 500 millisecond on, off, on, off, on, off, on, off. This is basically loop. They loop and loop and loop and loop forever. So the LED is blinking forever. Okay, as long as you provide power to them, they will loop forever and ever and ever. Okay. Any question? Ada soalan? Very simple, right? So this is just an introduction. It's a hello world only. Easy? Seems to be very easy, right? For now. So you can test them also here in your, if you have Walkme running. So let me try the code, the same code, and then put it into Walkme, right? And then, oops, if I want to save the project, so let's try to run the project first. Oh yeah, sorry. The ESP32, they don't have this. They don't have the LED built-in. LED. They have, but why? As output, they have, or I might need to provide the value straightforward. Why is that? This case void loop is not declared in the scope. I already removed them. Put it point number 2. Digital write LED. I didn't have that anymore. Oh yeah, up here. This is this one 2. They don't have them. I'm not sure. Usually they do have. I think pin number 2. Yes.
Does this board even have LED?
Yeah.
Oh,
Hold
it
on.
doesn't.
Oh, they don't have it. This version. They do have it down here, but I'm not sure if this is the version that I use. No. Basically, there are 2 LED. There's a one LED up here. There's a one LED down here. So let me check the pin out first. I cannot see the pin out clearly. Let me stop this first. Let me just try to move them around. Can I move them? Okay. All right, so this is 5 volt. Okay, this is different version. So they don't have it up here. It's supposed to be here, one, because my version here ESP32. Yeah, they don't have. Yeah, unfortunately, they do have one. Do have two LED down there. So let me check ESP32 LED. ESP 32 LED pin. Which one they use? Blink RGB, the pin out they use is, but one is changed. The ESP LED on board is connected to pin number 2. Yeah, they do have that 2 LED down there. But this is basically the version. While for Arduino, it will be connected to pin number 13. Number 13. So if that's so, let me try to change them to number 13. So just select the correct pin down there. Because ESP, they have quite a number of flavor for the board itself. So it can be, so this is basically the way that they compile. No, not that number. I'm looking for this one. I'm not quite sure which. Is it blinking or not? No, no, that not this. This one. I'm looking for this LED. But there's also another. Maybe this is resistor. Right. Let's check on the documentation first. This is ESP. What pin number is on board? Most of ESP they use GPIO2. But for ESP32, the GPIO2 is different. You have to read them. 2 is 22, connected to D2. Or is there any pin number 2 here? The pin number is quite different from one to the other. So the D2 is 22. So is it 22? Sometimes that's why I don't like to use ESP32 much, because they have quite a number of flavor that you have to make sure, okay, this is your board. Okay. So if I'm using 32, will I be able to use them? There's a pin number 2 down there. No, not that one. Not that one. Okay, we might need to look which one that actually connected to this LED. Okay, so can be a little bit hard to look for. So again, this project is on what? Which ESP? What's the name of the library first? Let me just take all this out of the board first. This one is ESP32 only. This one is S2, this one is S3, this is C3. So this is only ESP32. The onboard LED here is not available for ESP32, unfortunately. For ESP8266, it should be no problem because they have an onboard LED up there. But you can also control the LED down here as long as they are connected to one of the pins. But again, you have to identify which pin and which board is this. Because usually I don't use this one. Okay? The one that I use all the time, as you can see here, you don't see there's any protruded sections of the header. Okay, there's only like flush. Okay, so this is basically the version that I use. There you go. You can see that. Okay, there's no protruded antenna, right? And this is the room version, room 32 version. Okay, there are quite a lot number of version for ESP32 nowadays, because this is very, very popular nowadays to be used in most of the electronic project. But unfortunately, many factory, they have their own. Okay, so like the room factory here, this is not MCU factory. So non MCU, they have their own. But this one, I'm not sure which one that they use. Okay. Even the pin out here also quite different, because the pin, this is clock SDD, SD1, clock one, and the other one is 5 volt, CMD, D3. This one is this, and the top is ground. 23. Okay, I think it's not the same because the pin out layout, they are the same. This is 3v3, this is 3v3, this is EN. Okay, so it means that this is the room. All right, so ESP32 room. I just want to access the LED, but the pin number, what is the pin number? The specific pin number for the ESP will depend on the ESP version. You can see that. No, so many. So the room 32 is, yeah, they use GPIO2, supposed GPIO2. They use them, but it doesn't seem to respond well. So they might use a different version of ESP. Doesn't seem to respond to the LED. Okay, doesn't seem to do so. But yeah, I hope you get the idea. All right, you get the idea. So here you can see different version of this, but most of them they use GPIO2. Oh, sorry, GPIO2 sometimes they different naming for them. So GPIO2, the names pin number is what? Yeah, it's correct. LED2. That just sometimes they require also to include this. I'm not sure why. Sometimes they wanted this. So let's try that. It doesn't seem to respond well. Okay, so that's the thing. That's why it always good to have one in hand. Okay, so for this one. So if I try to compile this on my ESP32, this is my ESP8266. Okay, I'm going to take this out and then I'm going to put the ESP32 version. Okay, so let me try the ESP32 version and then I'm going to try to compile with ESP32. So I'm going to change this to ESP32. So as you can see with ESP32, there's quite a lot of ESP32. Okay, so ESP32, the one that I use is with the which one? ESP. I think the one that I use most of the time is the dev module. They seems to work quite well. But there's a room, but DA module. I'm not sure what they are. It's quite a lot. Okay, you can see there. So many ESP32. There. Lolin. M5 stack. This is one of my favorite for hacking tools. No. There's so many of them. So usually, sometimes I usually use the ESP, only the default ESP32. The development module. So let me try this one first and let's see if we manage to get them to compile. So I'm not sure if this is available. So sometimes you can just try first. If the LED billing is not there, okay, cannot use that. So let me try to change to 2. They're not available in the library, the bot library. So try to compile that. Okay, this is just to verify the code is working. Okay, it seems to respond well. All right, so try to upload. All right, so you can see that ESP32 is basically faster, okay, in terms of upload. There you go. Now you can see the LED is blinking there. Okay, the LED is blinking. You can see that. Much easier. All right, so it means that the LED on board of this is pin number 2, connected to pin number 2 on the pins for the ESP. Right? So there you go. The one that I use here is a dev module. Okay, the dev module, which basically you can communicate with the room version, okay, the ESP32 room version. But if you choose ESP 8266, usually you don't have to worry much because ESP non-MCU will always in this format. Okay, there are a number of other format, but they're not for popular. And over the internet, most of the time, the non-MCU version, not the Lolin version. Don't get the Lolin version. Get the non-MCU version. So which is usually you're not going to get any issues with them at all here with the ESP2. But ESP32 a little bit elusive sometimes. You might get issues with a different library, different version. So choose correctly. Most of the project you can get away with ESP 8266, should be no problem. Unless you want more power, ESP32 will provide you power, and that can be clearly see when you upload the code much faster. All right, there you go. ESP32 running this more or less the same code, just because of the constant parameter is not there for the LED built-in, but we just straight away provide the value, should be fine. Any question? Ada soalan? Good?
Yeah, all good.
All right, cool. Okay, is it too slow, too fast? Just nice. All right, okay, so next, what we're going to look is, all right, those are the parameter. This is basically just the board parameter. So I've talked about this before. The CPU speed, the flash size is 4 meg, the internal storage. 4 meg is the internal storage. But the RAM is 124 kilobyte, I believe. Okay, comport may vary, right? So this is the upload, and this the older version they use this method, the dotted version uploaded, right? I've talked about this also. Run forever. You can see the LED, and here the D4 connected to this one. The D0 is connected to this one for ESP8266. Okay. All right. Debugging. All right. So this is basically one of the important topic in microcontroller, debugging. So usually in mobile, in application development, if you develop for web, desktop, Flutter, or any other programming language, Java, so it's very easy for you to debug. You can just look into the console menu, and then the error will spew to you very easily. Okay, so and then you can just solve the problem there. But here, if you want to, if your code is working, your code is running with no issues, you can compile them. But then you want to make sure that you get the value or the functions that you call, basically receive the passing data that you submitted to the function or to the method, or you want to confirm the value. There's no easy way of doing that unless you enable what we call as the serial communication. The serial communication, which allow you to print out the value on your Arduino IDE. So to be able to do that, here you need to enable what we call as the serial communication port baud rate. So the serial begin instruction here. So let me just do something. So this is just for the LED. So I'm going to create new project here so that you can just use this later on for your reference, but actually not that much. So I'm going to create a new project, and this is just to show you the example of a serial communication. Okay. So for programming in hardware, so you need to enable this in your development process. Once you completed everything, once you have your project ready, you can just remove them because they are no longer used. Unless you want to have like a serial communication with a different hardware or different, so you can enable serial communication again. But usually serial communication here in Arduino IDE, we use them for debugging purposes, making sure that the value that we have, all the functions that we initiate should be able to print out easily for us to see. Okay, because we are talking about hardware here. We're talking about hardware. We're talking about you cannot see them. You cannot just look at the hardware here and then you can see that, oh, I can see the codes inside here is messed up. You want to repair the code here. No, there's no way you can do that. Okay, you need somehow to be able to communicate. Sorry, to be able to communicate to the microcontroller and then talk to them and then let them know that you want to know what's going on inside here. So that's basically can be done through serial communication. And the way that you enable them is basically to give this instruction. So usually you need to enable the serial communication through what we call as serial.begin. So the serial.begin will require a baud rate, B-O-U-D. So the baud rate, B-O-U-D, the baud rate is basically the transmission speed between your USB cable to the microcontroller. And the ESP8266, they run usually for the serial communication, it run at 115,200 bit per second. So that's why we define the baud rate as 115200. So this is basically the speed that we're looking at. The baud rate 115200. Yeah, 115200. So 115,200 bit per second. So this is the communication or the baud rate speed between your USB and the microcontroller, and you should be able to communicate back and forth with your microcontroller to ask them or to ask the microcontroller what's going on now through your serial command. I hope that makes sense to you. All right, so like for example, right now, I can enable them, and then if I wanted for the microcontroller to print out something, so the example here, let's say like, usually once we initialize something, we would like to put certain amount of delay. So that's why from time to time, you can see that there's a delay instruction there. So just put it like 100 milliseconds should be okay, so that your hardware is ready to move on. Okay, so put a delay there. And then to print out something, you can just use like serial.println. Okay, so this is basically like your C programming, serial.println. And then down here, so you can just hello world. Okay, from or hello from the world of ESP8266. Okay, so it should be able to print out in your serial monitor. And if you want to print out something else, let's say like serial.println, like here, yes, about printing the value of I, and then you can just do looping for integer I equals 0. This is just a normal loop, for loop. We use I is less than, let's say like 100, and then I plus plus. And then you just do something here. So serial.print line the value of I. So that's basically will print out the value of I in new line. Okay, the print line is new line. The print is on the single line. So if you want to do that, should be okay. So just put it like the value of I is, okay, and then serial.print or serial.println the value of I, and sorry, and then if you want it to run a little bit slow, you put it like some delay inside here. So put a delay like around like 200 milliseconds. So it will accumulate based on the number of loop that you have inside. So we'll see from there. All right, so this only run inside setup. So it means that it will only run one time. Okay, it will only run one time. So if you want to run this forever, you can put it inside loop. Okay, but here I just want to run it one time. So just do this. All right, so now every time you want to run, you have to save first. So where on earth I put it on inside here. My OneDrive is sometimes messing with me. All right, so I'm going to put it inside here. So I'm going to put like serial example, save there. Okay, you can always verify first if you want to, but this one is running on ESP32. So I'm going to change back to ESP8266. Okay, nothing wrong there. So I'm going to select back Node MCU version 1, and I'm going to connect them back to my Node MCU. There you go. Connect them. You can see the serial is up, and then just press OK. All right, so I'm going to upload them. Press this button. Okay, wait for the upload. Connecting. You can see the speed a little bit significantly slow compared to ESP32. ESP32 is basically much faster. There, 100% completed. All right, so how do you see the result? Okay, where do you see the result? How you want to be able to communicate with your board? So the board basically you have to turn on the serial monitor. So the serial monitor is basically up here. Okay, so the serial monitor, it basically will monitor the serial communication between your ESP with your Arduino IDE. All right, but now you can see that your the output down here is basically spilling what we call as a gibberish data. Okay, this is gibberish data. So reason being is that the baud rate here, right? So let me just put it up there. So your baud rate here is not properly set up. So the baud rate by default Arduino IDE or the Arduino microcontroller, they use 9600 speed bit per second. For ESP, since we define here is 115200, so we need to choose the 115200 as the baud speed. All right. So make sure that your serial begin, basically they are the same here. And if you want to try it again, making sure that you have the correct one, so you have to press, there's a button reset down there, RST. To the left, there's RST button. To the right, there's a flash button. Usually the flash button, we don't use that, but we use the reset button. So to be able to rerun back your code, your ESP will reset back to setup. So you just press the button. You should be able to see that. You can see that? Down there. Okay. So you can see down there, the value is printing until 100. And there's a delay to 100 millisecond for every printing. And that's the value of I. It's very simple as that. Okay, 99. We'll stop at 99, definitely, because it's less than. Okay, so it's less than, it start with 0, but since we use less than, not equal with, so it will stop at 99. Right, so that's basically serial communication. So for the serial communication, basically allow us to get, like, if you have any variable up there, or if you have any value that you want to print out, you can just serial.println and then put the value inside there. You should be able to see the value in here. And just to confirm the value that is it the correct value, or the sensor value is properly read from the sensor. Okay, so you can just print out the sensor value there. It should provide you with the sensor value. And if you don't have the sensor value, you connected everything okay, but the sensor value is not showing there. So it means that somewhere inside your code is incorrectly defined. Like for example, you have issues with the when you define the pin, the read pin, the sensor pin to a different value that is not in your that is incorrect. Okay, so it means that your sensor is not telling you the correct value because your pin mode is, you didn't put it in the right pin. Okay, so there might be issues. So you can easily see from there the value of the sensor data. All right, so that's basically the serial begin. Okay, so on the older version, it will pop up on the screen. On the new on the Arduino 2.0 and above, it will show at the bottom down there. Okay, so you can just, if you want to look bigger, you can just go there. So if you want to clear the value, you can always clear that the value inside there. So you can get fresh value later on. All right. Any question for the serial communication? Very easy to use. Okay, should be very clear, right? Ada soalan? Or anything common issue? There are common issues sometimes you might face with Arduino. This is not for sure process. Okay, just like any other programming, you might have issues with this. Okay, so sometimes this is one of the common issue. They call it permission denied. Whenever you try to compile them, suddenly you receive this error. So this error is due to your antivirus. Okay, certain antivirus they stop your access because whenever you want to compile things, your antivirus sometimes they being overprotective. So being overprotective, and it is true if you buy one, the paid version, and the paid version usually will do a lot of checking whenever there's a program running trying to do something with your storage, with your hard drive. So you have to look into that. You have to add exclusion to your antivirus to the directory of the Arduino directory. So add exclusion zone. So it means that it will ignore anything that came out from the Arduino IDE and the Arduino IDE library. MEM upload fail usually occur when the Arduino compiler unable to upload the compile. This is due to the serial communication is not properly established by the compiler. Sometimes your USB cable, okay? So USB cable, they are damaged USB cable, and then the USB cable unable to properly communicate with your board, even though they are connected. But sometimes the cheaper version, this one is quite cheap, and sometimes they have issues. So you get like the good one, the good version with braided and something like a good quality one. Okay, that one is better because it will be able to communicate, or even there's a higher speed USB. Okay, so use the good version one. Right. Okay, so next, this is basically just for understanding the digital pin out. Okay, so the digital pin out for the Node MCU. So whenever we want to program the microcontroller, so you have to really understand about deep understanding into the pin out or the usable pin out. Not all pin out created equal. So you have to understand them because certain pin out, they already connected to the onboard or there's already been used. Okay. For example, like TX and RX down here. So even though this is usable pin out, which means that you can connect to your sensor, you can connect to your LED, your relay or whatnot. But if you do that, or if you use this pin out, and you try to upload and your pin, the GPIO 1 and 3 being used or connected to a live sensor or a live relay, the relay that connected to them, you cannot upload your code because your ESP, your Arduino will assume that the RX and TX is busy with signal. So if you use them or you want to compile them, you have to take out first the sensor and everything, and then you can upload and then you can connect back later once you're no longer powered. But you might get issues with serial communication, okay? Because the serial communication, we use the RX and TX port here. So the RX and TX port will always be used if you want to read data between your Node MCU and your Arduino IDE serial monitor. Okay, so be careful not using them if you don't have to. The safe pin out for ESP8266 is, even though some of them connected to like the D1, the D2 here connected to the LED here, the D4 here connected to the LED down here, but they're still safe to be used. Okay, they can be connected to sensor and whatnot. Okay, this one also the same. Sometimes if you use like the RTS, the real-time clock, sorry, RTC library that use some of the pin out here, the clock pin out, the SD kind of pin out. So they might not be able to be very useful. So usually the safe pin to be used with your sensor and with your relay and whatnot is basically just D0 until D8. So more information, if you want to get more information on the ESP8266, you can use the random nerd tutorial. You can look at the pinout reference. This is very, very important. Okay. So this is the bare bone version. Usually we use this one. This is basically the label that they put in, and there's a multi-use. Certain pin they are multi-use. So usually, if you use this, print out this and put it on your somewhere so that you can just easily refer them. Okay, this is the VMOS version. It's a smaller version, but this is the one that I best use pin. Okay, so I didn't have them in the in your my chat. Oh, I didn't turn on my chat there. Okay. Itulah Syafiq, saya tanya juga tadi, siapa yang rasa slow sangat ke ataupun laju sangat. So, pada saya, ini just normal lah. And so, pada yang rasa laju sangat tu, you have to let me know lah. Okay? If you don't, I'm driving the car now. I'm driving. I'm the one who yang tekan pedal. So, I'm keep on pushing and my passenger seems that everything seems to be okay. They are happy with the speed. So, I'm okay with the speed. So, I keep on pushing the speed. Nobody say anything, so I keep pushing the speed. So that's up to you to stop me. So if you let me, I'm going to drive like 200 kilometers per hour if you don't stop me. Okay, because I'm used to this. Okay, but that's up to you. You don't talk to me. Hey, that's your problem. Okay, you don't talk. I cannot read your mind. I'm not a Jedi that being able to read your mind through my lens here and then, oh, this guy here unable to follow me. I have no idea. Okay. So keep on pushing and pushing and pushing and pushing until I'm not sure. Okay. I love the speed. Okay. Because I can cover more. There's so many things to cover here. So no one say anything. Shafiq seems to think okay. Saleh seems to be okay. So seems to be okay. All right, so this is basically the table that you have to refer all the time because this is an indispensable table. Okay, as you can see the label here, they are not the same. Okay, you have to understand this. The way the ESP8266 or ESP microcontroller, they have label. Okay, so if you look at, they do have label on board. Okay, you can clearly see sometimes on the board itself, there's a hold on there. The D0, D1, D2, D3, but they are not the GPIO number that you use in the programming. You cannot just use D0, D1, D2, D3. No. When you do the programming, you need to use the GPIO number, this number here. 16, 5, 4, 0, 2, 14, 12, 13. So you have to use that. Okay? That is the programmable pins. Not this is just for the label. This is just for the label for the, what they call it as a silk screen label. This is label. Okay? But the code is different. The code is the GPIO number, pin number. Okay? So don't get confused. Like this is 2, but the label is 4. You're going to use 4. You need to use 2. The label is 40, the label is 5, but the pin is 14. You need to use 14, not 5. Okay, so that's the thing with microcontroller, the ESP. They have a little different kind of arrangements because they are not by default programmed using Arduino IDE. They use different different IDE. Okay, but since the popularity of Arduino IDE, and then someone built the board manager for ESP, and then things the things change to Arduino IDE. So now Arduino IDE become the default for programming IDE, for programming the ESP. All right. So if you want to use, usually if you want to build the power save project, so usually you don't use the D0, because D0 usually you need to connect to ground. Okay, you need to, I think, yeah, to ground, for to ground or to high voltage, to ground. Okay, to ground. Okay, you need to connect this D0 to ground. If you want to use what we call as a deep sleep mode, they call it deep sleep, tidur mati. Okay. Yang ni kalau kata awak nak run something from the battery, like yang saya ada battery dekat sini ni, di battery ni. This is a LiPo battery. It's a very, very small battery that if you want to develop anything like a smartwatch, ada lagi kecil. Ini lagi kecil. This is the upcoming project that I'm building. So this one lagi kecil saya ada. This one is 250 milliampere mAh. So it's very small. So you can see the size is just the size of my thumb, the battery here. This is a LiPo battery. This is 4.2 volt, which is can provide enough power for my ESP, because ESP is running at 3.2 volt. So I can step down the voltage to 3.3 by using the regulator, the power regulator. You come in 4 volt, you put out 3.3 volt. Okay, and then you can just easily power your ESP. You can use D1, D2, D3, D4. Okay, you can use them. 5, 6 should be okay. 7 should be safe. D8 should be okay to be used, but if you boot up and then you pull high, means that you provide power to the GPIO 15, your microcontroller cannot be run. Cannot be boot. Master kita dah habis ke? Dah lagi kan? 4:30, 9:30, 10:30. So kita ada lagi 30 minit. Alright. Alright. 13 also the same, high at boot. Okay, so usually you don't use TX-RX. For AO should be okay, because AO is only for analog input. So anything or any sensor that require analog input, you can just plug into the AO, because there's only one AO here, which is at the top bottom to the up here. Okay, so they put it AO. Sorry, here, AO, there. All right. AO means analog. D means digital. Okay. So they already digitalized. So whenever the value came in, there's an ADC. They call it analog digital converter. So the ADC be able to read the signal that came, so the digital signals that came from the sensor, and should be able to read the discrete value. I think 8-bit. They use 8-bit discrete value, and then it can be translated into data. Okay, I hope you understand about discrete and analog. So the discrete value means that it basically come high, low, and then with 8-bit, you should be able to get what's the value of, is it 1 or is it 0? Is it a what value in hex? They use hexadecimal, I think. So the decimal value, the machine value, so they can spill out, and then you can read the value in discrete value, and you can use the clock, and the clock basically be able to translate that into data. Okay, so those are, if you want to go into details, but we're not going to get into that unless you want to learn about multiplexer. Okay. Okay. Right. So usually that's basically the pinout that I use. I don't use like normally for your project or for my project, there's only like 1 or 2 sensor at most that I use, and 1 output. Usually LED OLED screen. Okay. So not much. Okay. So normally you don't exceed more than that. So 2 sensor, 1 display, more than enough with ESP, unless you want to connect to quite a number of sensor array. So that can be quite problematic. You might want to choose ESP32 because ESP32 will provide you with a lot of pinout. Okay, ESP8266 is like 6, 8. Okay, at most. Okay, you don't go more than that. But ESP32 you can go like 16 sensor. You can connect to them to the ESP. Okay, so yeah, that's the thing with ESP32. More powerful, and you can Bluetooth also. Analog AO, okay, so because they have the analog digital converter 0, which is usually marked on the silk screen A0. Usually the voltage is between the maximum voltage for analog, because you need to talk about whenever the analog value is between 0 to 1 volt. Okay, so the maximum voltage ADC is 0 to 1 volt. So if you're using the ASP bare chip, the bare chip, but if you're using the development board, basically the range of the voltage that can be read from the analog is from 0 to 3.3 volt. So you can use the range for 1 volt is 1024, so times 3.3. Calculator. So 1024 is for 1 volt. So you can times 3.3 volt. That's 3,300, about 3,400. It can be read, right? So 3.3 volt. Because the concept can be a little bit if you're not familiar with the voltage divider. The voltage divider is basically a number of resistors that being arranged to be able for you to read based on the division of the resistor value. So they call it voltage divider, internal voltage divider, but able to convert that to 3.3 volt. So hence the value is 0.3. So if you're using the development board, which is the AO is 3.3 volt. But if you're using the barebone mode, okay, this is the barebone, like usually we call it, this is barebone. So if this barebone, the voltage is between 0 to 1, unless you use a voltage divider, put a resistor in voltage divider mode, and you should be able to convert any 3.3 voltage incoming and then put it into 3.3. But usually you can just read between 0 to 1, so which is between the incremental value of 0 to 1024 step. Right. So there's an onboard LED. There's a flash button there, but the flash button usually, when the GPIO is load, this is the same as pressing the flash boot button. Pull low, any pull low lah. So it means that you want to program, but usually we don't use this much. But GPIO16 can be used to wake up the ESP from sleep mode, to wake up the ESP deep sleep. This is the one that I mentioned. So you connected GPIO16 to reset. There's a reset pin here, and then connect it to GPIO16 if you want to develop like a battery type application. Communication, but they don't have I2 square, I2C. But they do have SCL, SDA pin number 5 and 4. You can communicate I2C. Certain device like the one with display here, call it, this is a OLED display. They call it OLED display, where you can display your data on here. It came with 4 pins. There's a 4 pins there. You can see the 4 pins. So 2 for power, 3.3 volt and ground, and the other 2 for the SCL and SDA. So SCL and SDA is a communication between component. So you can communicate with the OLED display here, which is allow you to display data. So you want to communicate with this display, and certain display, they use SCL, SDA to be able to communicate. Okay, so they call it I2C communication. But it can be implemented through, they call it a software I2C. There are hardware I2C, there's a software I2C, but this one implemented through software I2C. The difference is that in terms of speed. Okay, the speed of hardware much faster, but this one is software. They just work just fine, no problem at all. ESP also support SPI communication, so through MISO and MOSI. MISO and MOSI, but they require more pins here. Okay, they require 4 pins, at most 3 pins for the SPI. There are also some sensor. There are more advanced sensor they use on this. MOSI and MISO, something like this one. Not sensor. This is SD card reader. This is SD card reader. You can see that there's a number of pin there. So there's a SD card. If you want to read and write data to your SD card, you can, but you need to read based on the SPI. Okay, you need to read based on the SPI pin, because here, if you can see, I'm not sure there, you can see there, MOSI and MISO, MOSI, MISO clock. So you need to connect them to the pins on board. And then once you'll be able to connect, and then you can read through the MISO or MOSI, and then you need to configure them, and then you'll be able to read and write. It's basically like the project that I have here. So the project that I have here, you can see that there's a SD card reader there. There's a SD card reader there, which is then connected to my ESP through the MOSI MISO. So the pins done basically connected to them, and then I should be able to read data from my SD card. Okay, read and write. But in this case, I just want to read data. PWM, this is the post with modulation. This is basically able to generate PWM signal. Something like servo. I don't have servo here. Servo that can move up and down, so they can control the actuator. So for servo, they use PWM. So all pins can support PWM, means that you can connect multiple sensor, and then it can be used to run. So the one that I use here, okay, this is my camera robot here. This robot here. This robot here basically run based on ESP82. So everything inside here, wiring, you can see there, ESP8266 inside there. And then that's ESP basically connected to servo. So you can see the servo here. The servo, you can see the movement there. Okay. So this is basically controlled through the PWM signal. Controlled through the PWM signal. All right. So if I connect them to power, so I have a LiPo here. So the robot can be controlled. So if I connect the power there, it basically moves. The hand basically move automatically. So that's basically controlled through PWM signal. So that's basically PWM pin, and all the pins available on ESP basically supported PWM. Right, so the servo can be used, and now you can just develop the software that you can control the robot to walk. Right. Okay. So that's the pin out. What's time already? Tidak lagi. Okay, I've talked about that here. Okay, so usually which one that you can use, which one that you don't use. Normally which pin that I use a lot and I use less. So those are being described here. And if you want to make it easier, usually I can just define this in the programming, and then just put it like DO, D1, D2, D3, so that I can just easily refer them as D9 or D7 or D6. So just directly refer them, so I can just easily use this. If I don't want to use the number up here, okay, you can do that also, okay? Because sometimes it's much easier to see, okay, I want to connect to D3, so just use D3. I want to connect to D5, I can just use D5, okay, which is already mapped. This is just a map value, okay, just to map value to the correct pin out, so that I don't sometimes like I can just easily, okay, I just want to, because sometimes I don't remember, okay, this pin number is what, this pin number is what. So you can just use this and then automatically refer them very, very fast. Okay. Alright, or you can just print out and put it on your whiteboard there, on your board, and then you can just make a reference. Okay, I want to use this one, this one. Okay, D9 is 11, D6 is 12, D5 is 14. So you can just straight away use them in your code. Are you guys doing okay? Masih lagi bersama dengan saya ataupun sudah berada